So the first question, it says that the reaction has a positive value of 42 kJs of enthalpy change, and activation energy of the forward reaction is 135 kJs. And then for the y-axis, it's potential energy, and x-axis is reaction progress. And so we start from the reactant side at zero potential energy, and then we have to go up by 135 kJs of activation energy during the forward reaction, and then we have to do this curve to go back down in the progress in the products. In the end, we only increase like 42 kJs of potential energy. And so to get the reverse reaction, like the activation energy for the reverse reaction, we just have to minus 42 with 135 and get like 93 kJs, and that is the value of the activation energy during the reverse reaction to get down to the product side. Okay. The second question, it has two reactants with one product and one heat value, and since the heat value is on the right side, that means the reaction is actually just exothermic, so we have to lose heat to get to the product. And the activation energy for the forward reaction is 63 kJs, and we actually have to go up for a curve and then go down below our actual original potential energy of our reactants. And then we also have to indicate its activated complex on the diagram. So we start at zero potential energy with our reactants, and we go up by 63 kJs of activation energy during the forward reaction. It's also the activation complex. And then after we reach the top of 63 kJs, we just go down below the zero line of potential energy. We go back down further to negative 42 kJs of that potential energy to get to G, the products of the actual reaction, and then to find the activation energy of the reverse reaction is just by combining 63 with 42. So the total heat loss will be 105 kJs, and that will be the value of the activation energy for the reverse reaction. And the final part is to draw a second potential curve showing the effects of a catalyst. And since the catalyst speeds up the reactions, and therefore it also decreases its activation energy. So if catalyst has been used in this reaction, it will always have a lower activation energy for forward and reverse reaction. So to draw the line, it must be below the original curve, which has not used any catalyst. So for the blue line I've drawn is to indicate that catalyst has been used, and it will always be below the original line, which no catalyst has been used. It'll also end up the same enthalpy change when A plus 2D becomes G, because catalyst does not take part in the reaction, so heat has not been like destroyed or increased. And that is it.